Welcome to the DIY Honda Garage channel. The DTC Diagnostic Trouble Code P16F4 indicates a low voltage condition in the starter cut relay 2 control circuit of the Honda Fit models from 2015 to 2020. The starter cut relay is an essential component that prevents the engine from starting under certain conditions, providing safety and security. This relay is typically located in the under-hood fuse and relay box, making it readily accessible for inspection and testing. Low voltage in this circuit can lead to starting issues, which necessitates careful diagnostic steps to identify the root cause. Understanding how this circuit functions is crucial for accurate troubleshooting and repair. In this presentation, we will go through detailed steps to diagnose and resolve the P16F4 error code. The starter cut relay 2 is integral to the vehicle's engine management system, controlling the engagement of the starter motor based on input from various sensors and systems. Positioned within the underhood fuse and relay box, this component works in conjunction with the engine control module, ECM, to ensure safe engine starting conditions. If the system detects issues related to voltage in the control circuit, it can inhibit the starter motor from engaging, thus preventing the vehicle from starting. When diagnosing DTC P16F4, recognizing where the relay is located and understanding its relationship with the PCM, powertrain control module, are essential. These details assist technicians in effectively pinpointing the problem's origin within the circuit. Additionally, if there is a confirmed DTC code, it signals that the system has recognized a significant issue that needs immediate attention to restore normal functionality. Several potential causes can lead to a DTC P16F4 reading. A short circuit in the starter cut relay 2 control circuit could cause a short to ground, resulting in insufficient voltage levels detected by the PCM. Conversely, an open circuit could prevent electrical signals from reaching the starter cut relay, also leading to low voltage conditions. Additionally, issues with connectors or the relay itself, including corrosion or poor connections, may contribute to this problem. If the wiring and connectors appear to be intact, the PCM should be examined for faults, as it may not be sending the appropriate signals. Each potential cause emphasizes the importance of careful inspection and testing to ensure reliable operation of the starter cut relay circuit. The symptoms associated with DTC P16F4 primarily revolve around starting difficulties. The most noticeable symptom is that the engine may not start at all when the key is turned, indicating a failure in the starter engagement. This could present as a complete absence of activity from the starter motor or intermittent attempts at starting without success. In some cases, you might experience unusual behavior where the engine may start sporadically, which often points toward electrical connection problems. These symptoms can be frustrating for drivers and can lead to further complications if not addressed promptly. Understanding these signs is pivotal for technicians to accurately diagnose and resolve the underlying issues effectively. The first troubleshooting step for DTC P16F4 involves starting the engine to verify if it will engage. This simple engine start check is crucial, as it determines the initial condition of the system. If the engine starts, it indicates that there may not be a persistent issue, allowing you to proceed to the next step in the diagnostic process. However, if the engine does not start, this could confirm a fault in the starter cut relay or associated circuit, directing you to further investigation. Identifying whether the engine starts is an essential aspect of confirming if the DTC is indeed indicative of a problem that requires intervention. In the second step of troubleshooting, you will turn the vehicle to the off mode, followed by the on mode. This action is necessary to reset the system and prepare for further diagnostics. Once you have cycled the power, you will utilize the HDS Honda Diagnostic System to clear any existing DTCs. This step is critical as it allows you to clear any previous diagnostic codes that may not be current anymore. After clearing, checking for pending or confirmed DTCs is essential to determine if the problem still exists. If DTC P16F4 appears again, it confirms that a fault persists, and you can proceed to the subsequent diagnostic check. Step 3 requires you to turn the vehicle to the off mode and carefully remove the starter cut relay 2 from the underhood fuse/relay box. After removing the relay, it is essential to jump the SCS service check signal line using the Honda Diagnostic System. This connection effectively allows you to simulate conditions for further testing. Following this, you will disconnect the PCM connector A51P to isolate the control circuit. Testing the resistance between designated test points will now yield critical readings about the circuit's integrity. This step is vital to understand if the wiring is intact and not shorted or damaged. In troubleshooting step 4, you will turn the vehicle back to the off mode and then disconnect the PCM connector A51P. With the vehicle now in the on mode, you will conduct a voltage measurement between specified test points. This procedure will help assess whether the circuit is receiving adequate battery voltage when supposed to. It's crucial to note that any detected absence of voltage signals an issue with the wiring or potentially the PCM. Ensuring the PCM receives the proper signals is vital for the overall performance of the starting system. If the measured voltage is not within expected parameters, further investigation into the circuit will be required. Step 5 focuses on checking the continuity of the starter cut relay 2 control circuit. As with the previous steps, make sure the vehicle is in the off mode before performing any disconnection. After confirming the disconnection of the starter cut relay 2, you will proceed to check for continuity between the designated test points. Ensuring that the circuit has continuity is essential for confirming that no breaks in the wiring exist. If continuity is confirmed, it affirms the integrity of the ST-cut RLY2CL wire, allowing you to move forward in your troubleshooting process. However, if continuity is absent, it implies that there is an open circuit that necessitates repair before successful vehicle operation can resume. The sixth troubleshooting step involves inspecting fuse number C26, which is critical in maintaining power to the starter cut relay circuit. This 7.5A fuse is located in the under-dash fuse and relay box, making it relatively easy to access for checking. If the fuse is intact, you can continue troubleshooting. However, if it is blown, it's necessary to replace it. Replacing a blown fuse involves understanding the underlying cause, as it may indicate a short within the electrical system that requires further examination. Fuses protect circuits, and frequent blowing could signify deeper electrical issues that need addressing. Proper identification and resolution of fuse issues are crucial for maintaining reliable vehicle performance. In the final troubleshooting step, disconnect the under-dash fuse/relay box connector Q. Then, connect terminals A and B with a jumper wire for testing continuity. This step is crucial to verifying the IG1 ST-cut RY line, which is part of the starter cut relay circuit. Measure continuity between specified test points while ensuring the vehicle is powered off. A positive result confirms the integrity of the wiring, allowing you to replace the under-dash fuse relay box if necessary. Conversely, a lack of continuity indicates an open circuit that needs repair in the IG1 ST cut RY wiring. Addressing these wiring issues is fundamental for ensuring the starter cut relay operates correctly and the engine functions as intended. After completing the troubleshooting and necessary repairs, it is critical to verify that the repairs were successful. This involves rechecking the diagnostic codes using the HDS to ensure no DTCs remain active. If the repairs were effective, you should see no faults related to the starter cut relay 2 control circuit, including the P16F4 code. Additionally, proper functionality of the starting system should be confirmed by attempting to start the vehicle. If the vehicle starts successfully and operates without problem, it indicates that the repairs have resolved the issue. Finally, resetting the system may be necessary to clear any historical codes, allowing the vehicle's computer to adapt to the changes made. Preventive maintenance is an essential aspect of keeping the starter cut relay circuit functioning correctly. Regularly inspecting wiring and connectors for signs of wear or corrosion can prevent future issues from developing. It is also advisable to ensure that the software in the PCM is up to date, as manufacturers often release updates that enhance performance or resolve known issues. Consistent maintenance practices can significantly reduce the likelihood of encountering DTC P16F4 in the future. Moreover, protecting wiring and connections from moisture and debris will extend their lifespan and reliability. Performing these routine checks can save time and costs associated with unexpected repairs. In conclusion, understanding the importance of DTC P16F4 and its implications on the vehicle's starting system is essential for effective troubleshooting. Through a structured approach to diagnostics, including verifying symptoms and analyzing circuit integrity, technicians can accurately pinpoint and resolve underlying issues. Following through with corrective actions and preventive maintenance practices will contribute to a more reliable vehicle that maintains optimal performance. Being proactive in addressing potential problems before they become significant helps in enhancing the driver experience and overall safety. In summary, thorough knowledge and systematic approaches in addressing DTC P16F4 will ensure a well-functioning Honda Fit from 2015 to 2020. Please like and subscribe to the channel. See you next time.